Good morning, neighbors. Overcast Monday, hoping for rain, fingers crossed. Maybe it'll come. Pardon. So, alpha particles. Back to those things again. It doesn't stop. That's part of the reason I've been quiet, is trying to reconcile some of the conversations here. I have specifically avoided for years talking about subatomic particle interactions, other than the harm they can cause, measurable harm. We have tables of measurements and statistics on the harm of some of these particles. We do this, the EPA does this for chemicals and compounds. We study how hazardous they can be, and somebody makes a decision we can live with. I think that's the idea, decisions we can live with, right? So an alpha particle is part of the emissions, possible emissions, from radioactive materials. There's beta particles and there's gamma particles. Those are the three main particles that are discussed in a nuclear accident. But there are other things going on in the background that make these stories longer, make these stories months and years of classroom work to be able to begin to understand the stories. So here's a bit of why this is so complicated. I've talked to alpha particles, alpha emissions. They're a subatomic particle spit out of the nucleus of an unstable atom. That's where these particles come from. They can be accelerated, they can be changed. You've heard of particle accelerators. Now these particles, these are the realm of CERN and the work CERN is doing, trying to understand what is in the core, the nucleus of an atom. And you have to remember, there's thousands of different types of atoms out there. There's the periodic table of elements, which implies there's 110 atoms or elements. But when you look deeper, it explains itself when you learn about how that periodic table works. I don't look at it from a chemistry standpoint, though, because I'm not a chemist. So, alpha, beta, gamma emissions, each one of these has a specific harm rating. These are tables held by somebody that says, if you're exposed to this, here are the risks. Doctors, look out for these risks of cancers, of growths, of changes in, white blood cell counts, to show how much your body is working, trying to repair itself. So, alpha particles are part of the emissions. Somebody has brought up, and it's a fact, that the alpha particles predominantly can and will turn into helium atoms. Now, helium's an inert gas in most cases. It does not interact with other gases. It's also a mono. It does not bind to other things, basically. Once it's formed, it's just kind of there. So, yes, an alpha particle could turn into a helium atom, but on its way, it can do harm to whatever's in its path. Something decayed to make that alpha particle. The alpha particle does not travel far in the atmosphere or in air, or when it strikes your skin. It is dissipated, absorbed. It is satisfied in its search for additional electrons when it runs into your skin, or if it gets past your skin, because there's an attenuation factor going on here. And how deep, what are the odds of this particle getting in deeper? So the alpha particle becomes rather interesting to measure, because if it is in the air, it's posing some risk to you. Infinitesimal in normal life, until you start inhaling, until these particles that have not expired, have not decayed, begin to come in contact with mucous membranes, like your lungs, like your sinuses, like your, if you're wet, they have, that particle itself has a chance to adhere to your body. Now when it explodes, its travel distance is much shorter because there's more things to run into. So it's not just the alpha particles. The alpha particle is alpha measurement is giving you a hint there's something to be concerned of in the atmosphere, in the air itself around you, because of that inhalation factor for those atoms that have not decayed yet. And statistically, you survive these things. It's nothing. It's a big nothing in your body. This happens all the time. You shed skin cells. This is the actions from the sun, radiation from the sun. Only the alpha particle is worse. Beta is even worse. Gammas are interesting because the chances of them hitting something are so small that it's confusing. So these alpha particles is a legitimate conversation about health and safety. An alpha meter that measures specifically alpha is more sensitive to it, knowing how it works. My meter is not an alpha meter. It is a it's complicated. It sees alpha, beta, and gamma. So you have to learn how to discriminate between alpha, beta, and gamma using that meter. Or you have to go buy another meter that can measure alpha. So here comes the bigger conversation. This stuff should be monitored for across this nation, across North and South America, North America particularly. Because like those particulate matter filters, those numbers about particulates in the air that so concern people for breathing, for health and safety reasons, what are those particles? What's in that air besides the EPA's 2.5 ppm standard? So this story, this knowledge, this understanding touches sciences across the planet. Europe has decided that this monitoring, this requirement for a good quality of life is necessary. America is debating if that level of monitoring is necessary. And it should be public debate. These detectors also tell us about the rest of the health of our atmosphere. They tell us other things because these are science endeavors to collect information. And then you say the word science and people go, oh, science. So, very big connection, the dots in these stories. Thank you for listening.